Hey everybody, AmpRepairGuy.com here. Okay, so we're going to do the test on this box. We had to fix a couple things yesterday, one of which was the fact that the power supply had a 4 ohm resistor in there for the soft start, and every once in a while it would trip the breaker. So we put a 20 ohm in, now we're good to go. I had to replace the relay under here too. I was hanging up. Okay, so we're going to simulate the same test as before. We have just to recap, we have the fluke high voltage probe connected to the RF cold end of the plate choke, where it's fed the B positive from the plate supply. We have the fluke 289 meter connected to the probe. Let's wake this one back up. We have the fluke 287 connected to the line. I'll just shut off too. And then we have the fluke 322 current meter. Yeah, I'm sorry for the mess. I work here. I'm busy and I clean and it gets messy again. So this time we have it across. We have the current meter reading one leg of the 240, but we're not isolating the primary of the transformer from everything else this time. So we'll have an extra amp or so, for the blower and little other things, supplies that run the relays. It's minimal. So we have 244 here, so we're going to excite it. I found another set of tubes for this so I can drive it a little bit harder. So this time I have a 1 kilowatt slug connected to the line section over here, so that's between this amp and this amp, and then a 10 kilowatt slug, which I'll show you after. Actually, I'll just show you right now, between this box and the commercial dummy load down in the basement. I have a big 20 kilowatt dummy load. So that's a brand new slug. Coaxial Dynamics 10K. So. Okay, once again, this thing came from a ham radio operator. Originally went to another guy who was a ham. I got it in like a deal and it was sold to another ham. He's going to use it when in a legal manner, legal limit or less. So I did not make this. I repaired it, and that's it. So, okay, so there'll be another video after this. I'll show all of the readings and stuff, and then I'll explain everything after. I'll show you the static plate current voltage drop, and then I'll load the transformer down, and I'll analyze everything after in a second video. So let's get started. Okay, so the breakers are on. I have to manually key this box when I go to key it. This meter isn't accurate like I thought. It shows a little over 10. So we start off with 6,400 volts. So we're just going to key it with no RF. No RF's going into it. See, nothing. Just going to key it. It drops down about 200 volts. The line's at 243, so it drops a volt. 6.254. Okay, so now we're gonna we'll key the radio first. Key the amp first. Key the radio. Actually, keep the driver. Okay, so that's 2K right there. 2, 4, 6, 8, 10. So 2K, it's dropping to 5.9. We have 242. It's gone 17 amps. It's about 150 or so. The thing's not in perfect tune. So 4K right there, it's dropped 5.7, 22.27, 241. I'm gonna have to tune it up better, but okay. So we'll start at 4 for now. 5.7, 241, 22.19, 5.7. back it down. It's only in the 30 amp breaker. Okay, so we'll bring it up to 6K. 5.6 kV, 30 amps, 240. I'm not going to go crazy with the thing. Back it back down. So that gives you an idea of the voltage sag with one of these things. I will do a second video to analyze everything, give you a better idea of got the top off this, getting dosed with all sorts of RF for the teeth. But okay, so I'll do a second video in a little bit to explain everything you saw. And like I said, it was just dead carriers, and this thing wasn't. In all fairness, it wasn't, tuned for max output, so the amount of power was drawing off the line was just, relative. It wasn't running, I'm sure, at its peak efficiency. But for testing, this one's only hooked up to a 30 amp breaker. And I only have this little driver, so the purpose of this test was just to give you an idea of the regulation characteristics of one of these transformers. So, thanks for watching, and I will be back with a second video soon.